In this tutorial, I'll teach you to create a full-stack application using a powerful combination of technologies. Some people call this the farm stack. We'll be creating a full-stack to-do application using FastAPI on the backend, React on the front end, and MongoDB for the database. Also, we'll use Docker so we can develop, ship, and run our application in a container. This tutorial is great for beginners who already know the basics of HTML and JavaScript. You'll gain hands-on experience by integrating these technologies to develop a robust and scalable to-do application. So let's get started. So let's start with setting up everything for the project. We'll set up the project structure. First, we'll create a new directory for the project, farm to do, and switch to the directory. Then we'll create subdirectories for the backend and front-end section. Next, we'll set up the backend environment. So we'll go to the backend directory and we'll create a virtual environment and then activate it. Then we'll create the files, the Docker file and pyproject.toml, which I'll be explaining more in a moment. And then we're going to install the required packages. So FastAPI, this is what we already talked about. We're installing it with the all extra, which includes additional dependencies like UVcorn for serving our application. And then motor is an asynchronous MongoDB driver for Python. We're using the SRV extra, which adds support for MongoDB's SRV connection strings. And then Beanie is an object document mapper for MongoDB built on top of Motor. It's going to allow us to define our data models as Python classes and provides an intuitive API for database operations. And finally, AIO stream or AO stream. This package provides tools for working with asynchronous streams, which can be useful when dealing with large data sets or real-time data. Now that we got those installed, we can generate the requirements.txt file. And we've already installed the dependencies, but if we still needed to do that, if you're trying to set up this project on a different computer, you can install the dependencies using pip install -r requirements.txt. Okay, now let's go into our Docker file and we'll add the following content. So a Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. It's essentially a blueprint for creating a Docker container. So let's look at this Docker file. We have from Python 3 that just specifies the base image we're using. In this case, we're starting with an official Python 3 image. It gives us a pre-configured environment with Python installed. Then we have the workdir user/src/app, which sets the working directory inside our container. And then copy requirements.txt. This copies our requirements.txt file from our local machine to the current directory in the container, which lists all our Python dependencies. Then we have the run pip install, and then that whole line there. This command installs all the Python packages listed in our requirements.txt file. And the expose 3001 informs Docker that our container will listen on port 3001 at runtime. Then we have the command cmt python and the src server.py. This is the command that will be executed when our container starts. It runs our server.py file located in the src directory. With this Docker file, we're creating a reproducible environment for our application. Anyone with Docker installed can use this file to build an identical container, ensuring consistency across different development and deployment environments. Which makes me remember that if you don't have Docker installed, you're going to have to install Docker on your computer to follow along with the rest of this tutorial. And you can just kind of search up another text-based tutorial, just search install Docker, and then figure out how to install Docker on your computer. The pyproject.toml file is a newer standard in the Python ecosystem, which is introduced in PEP 5.18. It's designed to be a centralized configuration file for Python projects, which replaces many tool-specific files like setup.py and then others like that. So this can contain configuration settings for various tools used in Python development. So in this specific one, this tool.pytest.ini options indicates that we're configuring PyTest options. So in this course, actually the testing is beyond the scope of what we're going to do, but this is just kind of setting it up for later if we wanted to introduce tests into our projects. And the Python path equals src is just telling PyTest to add the src directory to the Python path when running tests. Again, this is just setting up for if you want to add tests yourself later, and it's just kind of best practice to have this in there. Okay, speaking of the src file, let's set up the backend structure by creating an src directory inside the backend directory, and then we're going to create two files, server.py and dal.py. DAL stands for the data access layer. The DAL file is responsible for handling all interactions between application and the database, and it abstracts the complexities of database operations from the rest of the application. So let's create dal.py. I'm just going to paste in some code here. So like I said, this is going to handle the interactions with the MongoDB database. So we're first going to import some stuff. We have the bson to handle MongoDB's object ID, which is going to handle MongoDB's object ID. I already talked about motor, asynchronous MongoDB driver, and then we have the pymongo for specifying return behavior and update operations. The pydantic.base model is going to create data models with validation, and then the UUID is going to generate unique IDs. Now we're going to have a few different data models. So we're going to have the list summary, which represents a summary of the to-do list, the to-do list item, which is an individual to-do list item, and the to-do list, which is a complete to-do list with items. So each is going to have a from doc static method to create instances from MongoDB documents. The to-do DAL class encapsulates all database operations. So you see we have a list to-do lists, and it's just going to, and this code will asynchronously yield summaries of all to-do lists from the MongoDB database. We have the create to-do lists, which is going to create a new to-do list and return its ID. And you can see all this code just uses standard what you would use when you're working with MongoDB. And then we have the get to-do lists, retrieves a specific to-do list, delete, pretty self-explanatory, deletes a to-do list item. Then we have the create item, which is going to add a specific to-do list. And then the set check state will update the check state of a specific item. It's going to have to find the item, and then it will update it. And all this should look familiar if you're at all familiar with MongoDB, but if not, this is how it works. And then finally, we have the delete item to delete an item. Some key points about this file is that all methods are asynchronous using the async await syntax for non-blocking database operations. And there's also extensive use of type hints for better code clarity and IDE support. And this, you would notice that it uses various MongoDB operations like find, insert one, find one, and update. There's also data transformation, which converts between MongoDB documents and pydantic models for type safety and validation. And all methods accept an optional session parameter for transaction support. And then most methods return none if the operation fails or the document is not found. So this DAL file provides a clean type-safe interface for the rest of the application to interact with the database, abstracting away the details of MongoDB operations and document structure. Now let's implement the FastAPI server. So we'll go into the server.py file. I'll paste in this code. We're going to have these various imports up top for FastAPI, MongoDB, and custom modules. And a lot of these are, some of these are similar to what we saw in the other file. We're also going to configure variables for the MongoDB connection and debug mode. You'll see that we're using the the environment variable MongoDB URI, that's going to be the MongoDB connection string, which will create an environment, a .env file with that connection string later, and I'll show you how to get that. So we start off with this async context manager, and defining the lifespan function. This function manages the life cycle of the FastAPI application. We see what happens on startup, which is going to connect to the MongoDB and initializes the to-do DAL. It's going to ensure that the database is available and get the collection, the to-do list collection. And then on shutdown, it's going to just close the MongoDB connection. Then we have the app equals FastAPI with the lifespan, the debug. This is going to create the FastAPI application with the lifespan manager that we had just defined. Next, we get to the core of this, which is the API endpoints. So we're going to the GET request to API/lists is going to retrieve all the to-do lists. Then we have a POST request to API/lists, which is going to create a new to-do list. And we're just going to pass in a name for this one, which is just the name of the to-do list. Then the GET API/list/list ID is going to retrieve a specific to-do list. Then if we make a delete request, we can delete a list. And then if we post to API/list/list ID/items, we can add a new item to a to-do list. And we're just going to pass in the item name, or we can delete an item. And we can also set a check state, if you're going to check that an item is checked. We also just have a dummy endpoint for testing. We're not going to really use this, but we're just going to put it in there for future testing. Now, throughout this, we've been seeing these pydantic models like new list response, new item response, to-do item update, dummy response. These models define the structure of request and response data for various endpoints. And then we have at the bottom, we have our main function. This function runs the FastAPI application using UVcorn when the script is executed directly. So some of the FastAPI features that are demonstrated in this file is async support. All endpoint handlers are asynchronous, allowing for non-blocking I/O operations. We also have type hinting for request and response models, which improves the code clarity and enables automatic request validation and response serialization. We also have the path parameters with the endpoints like the API/list/list ID to capture the dynamic parts of the URL. We have the request body parsing, where FastAPI automatically parses JSON request bodies into pydantic models like the new list and new item. We also have the response models, which are the endpoints that specify return types, which FastAPI uses for response validation and OpenAI documentation. Then the HTTP status codes, which are the custom status codes that are set for certain endpoints, like we saw the status.http 201 created for post requests. And then dependency injection, the to-do DAL instance is injected into the app and used across the different endpoints. Finally, we have the Swagger integration. FastAPI automatically creates Swagger documentation for this API. Okay, we got that out of the way. Now let's actually create our database on MongoDB. So you can go to mongodb.com, and then you can either sign in or create a new account. And then after you sign in, you can create a new project. If you're creating the account for the first time, it may go into this automatically, but you may also have to select new project. So we'll just name our project, and then we can create the project. Then we just need to create a cluster. And we can choose what type of cluster we want to create. You're probably going to want to create the free one, which is basically just for learning. If your project gets really big, you can always switch to the paid one. Then create a username and password. Note I will delete this or change the password before this video goes live, so don't worry about seeing my password. And then after creating the user, we can choose a connection method. We're going to have to wait till our cluster is all set up. But after the cluster is all set up, we can go into the connection screen again, and we can, if we click through a little bit, we can see our MongoDB URI. This is what we're going to need to connect to our database. So just copy this URI, and then we'll go back into Visual Studio Code. And now we're going to need this URI for our environment variable. So in the root of our directory, we'll create the .env file, and then we'll create a variable, MongoDB underscore URI, all capital letters, equals, and then we're going to put quotation marks around this and put our URI that we just copied. We're going to have to make sure that we put in our password. Again, I'll be changing this later. And then we are going to have to put in the database name. This doesn't have to exist already. It will create this database if we don't have this. So after it says mongodb.net/, we're going to put to do right before the question mark. And that's going to create our database name. Okay, now let's create our Docker compose file. This is just going to be in the root directory of our project, compose.yaml. So I'll put in this code here. This is the Docker compose configuration file. And Docker compose is a tool for defining and running multi-container Docker applications. So we are going to configure it by adding the name. Services is going to define the different containers that make up the application. So we basically have three containers. We have the Nginx service, which is going to use the official Nginx 1.17 image, and it mounts a local Nginx configuration file into the container. And then it's going to expose port 80 in the container to port 8000 on the host. This is going to help reroute the front end and the back end to the correct URLs on our site. And it's going to depend on the back end and front end services. So the front end service, this is going to just specify using Node. The user is going to set the working directory and the user in the container, mounts the local front end directory into the container. It's going to expose port 3000 internally into the host, sets the environment variables, and then runs npm start command to start the front end application. Then we have the backend service, which is going to use the custom image built from the backend directory. It's going to mount the local backend directory into the container, expose port 3001 internally, and map it to port 8001 on the host. It's going to run the Python server script, and it's going to use this is how we get in the environment variable file that we just created, the .env. So yeah, we just have the three main sections: the Nginx reverse proxy that routes the request to the front end back end, the Node.js based front end application, and the Python based back end application. And this is going to basically create a consistent, reproducible development environment that closely mimics the production setup, and we can start the entire application stack with all three containers with the single command, which we'll do it later. So it's easier to develop and test full stack applications. So let's finish with setting up the Nginx configuration. So we'll create a directory named Nginx at the root of the project. We'll create a file named nginx.conf for config inside the Nginx directory, and we'll paste in some code. So this is going to configure our Nginx web server, which like I said, was used as a reverse proxy for the FarmStack application. So first we're going to define the server block. It's going to listen on port 80 for incoming HTTP requests, and then we're going to set the server name, and then we're going to create the front end proxy, which is going to forward the requests to the root path to the front end service, which is going to be running on port 3000. And then we have the back end proxy, which is going to forward the requests to the /API to the backend service running on port 3001. So this will make sure the host names front end and back end are going to be resolved within the Docker network, so we can use these names instead of IP addresses. And then we have the port mapping, the API routing, the WebSocket support. So this is basically going to allow us, Nginx is going to allow us to serve both the front end and back end applications from a single domain and port. And in the context of our Docker Compose setup, this Nginx container acts as the entry point for all web traffic and routes requests to either the front end or back end service as appropriate. Okay, time for the front end. We are going to set up the React application, which is the front end, both React. So we'll go to our front end directory and then create a new React application using create React app. Now, there's some more modern ways to create a React app with Next, but this is going to work just fine for what we're doing here. So we're going to install additional dependencies. This Axios is a popular promise-based HTTP client for the browser, and Node.js, which is going to help create the HTTP request from Node.js. And then we have React Icons, which is a library that includes popular icon packs as React components. And we are going to use some icons in our application. So now we are going to set up the main app component. So let's go over to app.js, and there's one that's already created by default, but I'm going to update it with all new code. So this is a pretty standard React application. We are going to import stuff like React hooks for state management and side effects, Axios, which we just installed for HTTP requests, some custom components that we are going to create. Then we have for state management, we have the list summaries that stores the list of to-do lists, the selected item that stores the selected to-do list. We have the use effect hook, which is going to call reload data when the component mounts to fetch initial data. And the reload data function, it will fetch the list of to-do lists from the API and updates the list summaries state. And you can see it's doing http.get API/lists. So this is going to our backend because of Nginx rerouting anything that's /API to our backend of our application. Then we have the event handlers, the handle new to-do list, that creates a new to-do list, handle delete to-do list, deletes, handle select to-do list, obviously selecting, and then back to list, which is going to clear the selected list and reload data. We have some conditional rendering. If select item equals null, it renders the list to-do list component. And if a list is selected, it renders the to-do list component for that specific list. And then we have some props passing. Various state values and handler functions are passed as props to child components. This app component serves as the main container for the to-do application, and it manages the overall state and orchestrates the interactions between the list view and the individual to-do list view. It handles data fetching, updates, and user interactions at the top level, and it passes necessary data and functions down to child components. So let's create the list to-do list component, which was referenced in the previous file. Let's create a new file called list-to-do-list.js, and we'll paste in some code here. It's going to start with imports, the component CSS file for styling, the use ref hook from React for creating a reference to the input element, and then here's we're gonna use the buy solid trash. This is an icon from the React Icons library that we installed earlier. Then we have a functional component, list to-do list, that's going to take 4 props. The list summaries, which is an array of to-do list summaries, handle select list. The function that handles, which is the function to handle selecting a list. The handle new to-do list, which is the function to create a new list. And the handle delete to-do list, which is obviously going to delete a list. And then we have the use ref, which is used to create a reference label ref for the input field. We also have conditional rendering. So if list summaries is null, it's going to show a loading message. And if it's an empty array, it shows a message and then the form to create a new list. Otherwise, it's going to render the list of to-do lists. So we got the heading, then a form to create a new to-do list, even if you already have a to-do list, and then it maps over the list summaries to render each to-do list summary, which is gonna each list is gonna have a name, a count, and a trash icon for deleting the list. And then there's a few events. If you click on a list summary, it calls the handle select list with a list ID. Clicking the trash is going to delete it. And then the trash icon click event uses the stop propagation to prevent triggering the list selection. And you can also, like I already mentioned, create a new list. So this component is purely presentational with all logic handled via props from the parent component. And this whole component serves as the main view for displaying all to-do lists, which allows users to view, select, create, and delete lists. And as you can see, it's designed to be flexible, which can handle various states of the application data efficiently. Then we're going to create the styling for this. So we're going to create the file list to-do list.css. And this is just some really basic styling. And then we'll move on to the to-do list component. So we'll create a new to-do list.js, which is going to be pretty similar, similar imports. It's going to have the component definition, the functional component to-do list with the list ID, and the handle back button function is going to be are the props. It's going to have some state here. And then the use effect hook, this fetches the to-do list data when the component mounts or list ID changes. And then it also updates the list data state with the fetch data. Then we have the 3 event handlers to create an item, delete item, or check the toggle if someone clicks that the to-do list item is complete. And the conditional rendering, if it's null, it shows a loading message, or it's going to render the to-do list with all the main parts of the list, including a back button. And then it just maps over the list data to items to render each to-do item. And for each to-do item, there's a checkbox, an item label, and the trash icon. And then we got the event handling. Clicking on an item triggers its check state. Clicking on the trash icon deletes the item. And then if there's an empty state, it will display the message there are currently no items. So this component manages its own state for the to-do list data. All the CRUD operations for to-do items are handled within this component, and the component is responsible for displaying the to-do list and managing the item. So it's basically a detailed view for a single to-do list. Then we're going to create the to-do list.css to style this. It's pretty basic. And let's update the main CSS file as well. We'll go to index.css, and then we'll just update the code with some basic simple styling for the CSS. So basically, we're done setting up the React frontend for the FarmStack to-do application. We created the main app component, the list to-do list component, the to-do list component, and it's basically complete. So now we're going to test it out. So in this part, we're going to run the application using Docker Compose. So like I said earlier, you gotta make sure you have Docker installed on your system. So we can open the terminal in the root directory of the project, and then we'll run Docker Compose up -- build, which is going to build and start the containers. Up means it just means it's going to create and start the containers defined in the compose.yaml file. And the -- build flag tells Docker Compose to build the images before starting the containers, even if they already exist. So first, like I said, it's going to read the compose.yaml file to understand the services, networks, and volumes defined in the application. Then for each service that has a build context specified, it's going to build a new Docker image using the Docker file in the specified directory. This happens even if an image for the service already exists, which basically means it's going to rebuild it. So once all the images are built, it's going to create and start the containers for each service defined in the compose file, and then it's going to attach to the containers and streams their input to the terminal. So now they should be up and running. We can go to the web browser, and then we're going to go to localhost 8000. So if you remember, it's actually using inside the Docker containers, it's using port 3000 and 3001, but that's being rerouted to port 8000. So let's test it out. A new to-do list, FarmStack course. And then if we click where it says 0 items, we can start adding some items. So let's just add a few items here associated with our course. And now you can see we have one of our lists is the FarmStack course 4 items. Now I'm going to create another list, a shopping list. We'll add some items to our shopping list. And you can see both lists on this page. If I click into the items, I can check them off when they're finished. Checking a few more off, I can delete some items. And you can see all that works. I can delete a list. Now let's go to our MongoDB Atlas dashboard where we set up our database. And I'll show you how you can see the data right from the MongoDB website. So let me refresh this page and we'll go to Browse Collections, go into the collection, and we can see here's the only item is the FarmStack course, and we can see the different items within this, which is an array, so we can see the different to-do items in this list. And we can even make a change right from this page. So I'm going to change this to write and edit articles. And then if I can click update here. If I go to my to-do list, and we'll see it says write and edit article. I can check and uncheck it. Okay, let me just add another little to-do list here with some items. Now I'll go back over to MongoDB Atlas, and we can see that list now appears in the list of items here. So we're done with the project. And thanks for watching. You should now hopefully be able to create a FarmStack application on your own. And remember, use your code for good.